ladies and gentlemen.
Let's talk factoring. Factoring is one of the most important fundamental skills when it comes to advanced math in terms of pre-calculus, calculus, and beyond, especially if you're taking an algebra-based course. Factoring is extremely important. So, when you factor, you're typically dealing with a quadratic in the form of ax squared plus bx plus c, and what you need to keep in mind is you're asking yourself the question in your mind, what is the a times the c? Easy question. Then, what factors of that number add to the middle? So sometimes you have to make some sort of systematic list in order to figure out what are the key things that you need, but that also means that if the a is 1, life becomes a little bit easier. So let's talk about some of those easy problems to start. So question 1, if x squared minus 9x plus 14 is equal to 0, what is the product of all possible values of x? So I have a 1. 1 times 14 is 14. What are the factors of 14 that add to negative 9? So what I'm going to do is I'm going to make a t-chart with a 14, and then what are the factors of 14? There's 14 and 1. There's negative 14 and negative 1. There's 7 and 2. And negative 7 and a negative 2. Now keep in mind that I wanted the sum to be negative. I could have just left off the positive ones from my list because I know that they're not going to be useful. And it's very easy to see that negative 7 and positive 2 are the right ones. Now if you have an easy one, if the a is 1, you can cheat a little bit. You can just go ahead and rewrite this as x minus 7 times x minus 2. There is a process to factoring called factoring by grouping that we're going to have to go through with more complex ones. But if you see a simple one, by all means, remember the trick. Just keep in mind that the trick doesn't always work, especially if you have a coefficient with your x squared. Now this brings up another key point. We have the zero product property. If I multiply two numbers together and I get 0, then at least one of them has to be a 0 at any given time. So what I can do here is I can actually set these apart as x minus 7 and x minus 2 to equal 0 separately. And I can solve them separately. So x minus 7 is equal to 0, add 7 to both sides, x is equal to 7. X minus 2 is equal to 0, add 2 to both sides, x is equal to 2. So x is equal to 7 or x is equal to 2. What's the product of all possible values of x? 7 times 2 is 14. So not bad, especially if the a value is 1. You don't have to do a whole lot of extra work after you find your magic pair of numbers. Let's do another one. So x squared plus 8x minus 20 is equal to 0. What's the greatest possible value of x? So when we find our two answers, we're going to take the larger one. So same idea. I have a 1 here, so negative 20. The factors of negative 20 that add to 8. Well, negative 20. Now, keep in mind that when I multiply to make a negative, one number is going to be positive, one number is going to be negative. I want the larger number to be positive if my sum is positive. So that means a positive 20 and a negative 1. I could have a positive 10 and a negative 2. I could have a positive 5 and a negative 4. And I do believe that those are all of the ones where the larger factor is positive. And I spy a magic set, 10 and negative 2. So this would factor to x plus 10, x minus 2. And we can clearly see that a negative 10 would make the inside 0 here, and a positive 2 would make the inside 0 here. The greater of those two values would be a 2. Not too bad. Now, if you have a coefficient in front of your x squared, we can try to factor that out first. Maybe we can make the problem simpler into one of those simple quadratics just by factoring out that a value. So if I look here, 27 is divisible by 3, and so is 42. So I'm going to factor out a 3 first. That gives me x squared. 3 times what is negative 27? That would be a negative 9. Now a trickier one, what times 3 is 42? Well, 42 is 6 times 7, which means it's 3 times 14. So plus 14 is equal to 0. Now I can factor this inside just like I did before. I'm going to make a t-chart with that 14 on top, and I'm going to have two factors, and both of them are going to be negative for this one. So 14 is negative 14 and negative 1, negative 7 and negative 2. Those are the only options. So I have my magic pair there. So this is 3 times x minus 7 and x minus 2. I can clearly see that a positive 7 and a positive 2 are my solutions here. The product, 14 is back. Not too bad. Now we have an interesting one. I can't factor a 6 out of 7 or 2. So here I'm going to have to actually go through the entire process of factoring. So 6 times 2 is 12. That's going to be the top of my t-chart. And I want to list the factors that add to 7, so I'm just going to keep them all positive. We have 12 and 1. We have 6 and 2. We have 4 and 3. And the one that we want is the 4 and the 3. So what I'm going to do is I'm going to rewrite this, but instead of the 7, I'm going to split the 7 into 4x and 3x, because 4x plus 3x is 7, right? So 6x squared plus 4x plus 3x plus 2 is equal to 0. So this order here doesn't matter. All that's going to do is if you switch the order, the list of your factors are going to be in the opposite order of mine. What I have first, you're going to have second. What I have second, you're going to have first, kind of thing. Now we're going to focus on each pair. So we're going to focus on this pair first. What's the greatest common factor here? Well, 4 and 6 are both divisible by 2, and x squared and x are both divisible by x, so I'm going to factor out a 2x, leaving me with 3x plus 2. Now I'm going to look at my second pair. What's the greatest common factor here? Well, 3 and 2 share no common factors, and x, there's no x's, so their greatest common factor is just 1. So plus 1, and we can then rewrite this as 3x plus 2, because we didn't really take anything out. We factored out a 1. It really doesn't change anything. Now if you look, we have a common factor again. We have a common factor of this 3x plus 2 in both of these terms. We have two terms here. They both share this 3x plus 2. So if I divide both by 3x plus 2 to factor that out, I get 3x plus 2 times 2x plus 1. That wasn't too bad. It is a little bit of a process, but it's a process that's unchanging. It's an algorithm. As much as I don't like algorithms, it's a very important one to know. So if I have 3x plus 2 times 2x plus 1 is equal to 0, how do I solve this? Well, 3x plus 2 is equal to 0, or 2x plus 1 is equal to 0. Subtract 2, so we get 3x equals negative 2. Subtract 1, 2x is equal to negative 1. Divide by 3, divide by 2, we get x is equal to negative 2/3, or x is equal to negative 1/2. Now, if it's asking for the least possible value, it wants the one that is furthest from 0 in the negative direction, and that would actually be this negative 2/3. So, not too bad. Now, this factoring, again, we can use it and we can consistently solve problems using this. The only time that factoring doesn't work out, and I want to bring this up now, is if we have solutions that are irrational, meaning that we can't write them as a fraction, or they're imaginary or complex. So in the realm of real numbers, that means that we're either going to get rational or whole number integer solutions with factoring, or if we can't factor, that means that there are no real solutions or there's irrational solutions. So just keep that in mind. So what if my equation is not equal to 0? Well, that means that I have to manipulate my equation so that one side does equal 0, so I can use that nice zero product property. So I'm going to subtract 2x from both sides, give me 4x squared minus 2x minus 6 is equal to 0. I can factor something out of all of these terms. There's a greatest common factor here, and that is 2. Factoring out that 2 gives me 2x squared minus x minus 3 is equal to 0. And this is not one of those nice simple quadratics. I got to do 2 times negative 3, giving me negative 6. Factors of negative 6 that add to a negative 1, well, that means that I need to have a negative as my quote-unquote larger number, one that has the largest absolute value. So that would be negative 6 and positive 1, or negative 3 and a positive 2, and it looks like the second one is our winner. So I'm going to rewrite this. So I have 2, parentheses, 2x squared minus 3x plus 2x minus 3 is equal to 0. Factor out the greatest common factor of the first 2, which would just be an x. And the second one would have nothing in common, so that's just a 1. So doing that, we get 2x minus 3. We get 2x minus 3. There's a nice plus in between. We do have parentheses all around that, so there's a lot of parentheses here. I do apologize. And then we're going to factor out that 2x minus 3 from both, giving us 2x minus 3, x plus 1, and that 2 out in front equals 0. Now, we still need to solve this. This one here is quite easy. The answer to this one would be negative 1, right? This one, not as easy. I can rewrite it over here. 2x minus 3 is equal to 0. We're going to add 3 to both sides. So 2x is equal to 3. Divide by 2, x is equal to 3 halves. So we get 3 halves and negative 1. If we add them together, well, 3 halves minus 1 would be a 1 half. So that would be the sum of all possible values of x. This last one I want to include because it's more of that standardized test style question. So we have let y equal 3x minus 3 and x minus 1 squared plus x minus 1 minus 8 is equal to y. If x comma y is a solution and y is greater than 0, what is the value for y? So we're solving for y here. And it might look evil. It might look like I'm just, the most evil person in the world. But look at the structure. I have y is equal to 3x minus 3. And I have this x minus 1 and x minus 1 here. There's a reason why that's in parentheses. This is a third of what I currently have for y. So if I divide both sides by 3, I get 1/3 of y is equal to x minus 1. So I can substitute this 1/3 y into both of those parts. So I get 1/3 y squared plus 1/3 y minus 8 equals y. And I can actually go about solving this. So if I square this, 1/3 times 1/3 is 1/9. Y times y is y squared. So plus 1/3 y minus 8 equals y. And you might be like, fractions, I'm getting the heebie-jeebies. We can do the exact same thing as we've been doing before, which would be to multiply by the least common denominator, which in this case would be a 9. So we're going to multiply every single part by 9. So 1/9 times 9 is just 1, so we get y squared. 9 times 1/3 would be 3, so we have 3y. 9 times 8, that's a pretty big number. That's a negative 72, and that equals 9y. Now, like we did before, we're going to move all of our terms to one side, so we have 0 on the other. So we have y squared. I would subtract 9y, so that would be negative 6y minus 72 is equal to 0. So I need to find the factors of negative 72 that add to negative 6. And that's going to seem like a very big, daunting task. But you can stop once you have the answer. I like to go about it systematically. So 72, I could have negative 72 and 1. Remember that I want to make the larger number, the number that has the largest absolute value, negative because they're summing to a negative. These are too far apart. Well, what if I do something a little bit nicer? I can do 2, and then half of 72. Well, half of 70 is 35. Half of 2 is 1, so that would be negative 36. That's still too far apart. I feel like I could take another 2 away, so that would be 4. And then this divided by 2 would be negative 18. That is still too far away. What if I take another 2? So I could have 8, and that would be a 9, negative 9. That's too close now. So what if I take a 3 instead? So I can start with this one here, and instead of taking a 2, I'm going to take a 3. So 36 divided by 3 would be negative 12. 2 times 3 is 6, and those sum to 6. So be methodical about it. You don't have to go through every single factor. There are more. Be methodical. So what I'm going to do is I'm going to split this one up. So I have y squared minus 12y plus 6 minus 72 is equal to 0. Nope, 6y. Greatest common factor here would be a y. Greatest common factor here would be 6. So I have y times y minus 12 plus 6 times y minus, and 72 divided by 6 is the negative 12, equals 0. I have y plus 6, y minus 12. So that means my two solutions are negative 6 and a positive 12. And I want the positive solution, so my answer would be 12. Now you might be asking yourself, why at this point did I go through the factoring the same way that I did for the complex ones? And I'll be honest with you, it just slipped my mind to do the simple one. My mind just automatically goes to do it in the complex way because it's always going to work if it's factorable. If you did it the simple way, it just means that you have less steps than I do, but you should arrive at the exact same answer, and I hope you see that it wasn't too bad. If you have any questions on this, please let me know. Otherwise, I'll see you in the next video.